Hi folks, my name is Chelsea Troy. You can find me most places on the internet as Hey Chelsea Troy, with the exception of my site, which is chelseatroy.com. If you like this talk, you'll love what you find over there. So today I'm going to talk about refactoring. We'll cover some technical details for the software engineers and some operational details for the product managers in the crowd too. So first, what is refactoring? Well, the canonical definition says something like changing the design of existing code without changing the user-facing features. Now, I don't actually love this definition because it comes with two assumptions baked into it. First of all, who is a user? So refactoring changes the developer-facing characteristics of a code base, and developers are users. Now, if the only way to write the feature that end users need is with messy code, then we let it be messy, because beautiful but unused code doesn't help anyone. But also, illegible code can't adapt to end users' needs because developers are afraid to change it. No designer wants to hear that a tweak to the animation is going to take 2 weeks. So we keep code in a maintainable state to reduce the wait times for code changes. There's another assumption baked into the term user-facing features. What is a feature? So we tend to equate user-facing features to content and navigation features. Think buttons, tabs, text, pictures, requests, that kind of thing. And sometimes we call these features functionality. Now that is one kind of feature, but it represents a very small sliver of the totality of features. So other kinds of features include scaling. Does the software work when a lot of users are on it? Does the app work when the network connection is heavily taxed or poor or non-existent? Or what about robustness? Does the software respond gracefully to unexpected input from the user or even from network calls? And then we have security. Does the software respond gracefully to when people try to compromise it, when a hacker might try to get in? Okay, how about accessibility? Does the software work for users who use screen readers or large font, high contrast UIs, loud and clear sounds? Does it work for users who have compromised motor control or dexterity? And then we have inclusion. Does your computer vision app work for people with dark skin? Does your software only ask questions about users' sex and gender if it absolutely must? And if it must, does it ask about those things in the right way? Those are all features, just like profile pages, buttons, and news feeds. And we often refactor precisely to get some of these features. Better error handling, for example, better network performance, better predictive results. But whether we'd call that a new feature or a refactor is unclear. By labeling our work as a feature or as refactoring based on whether users notice a difference, makes some assumptions about who is a user, and we don't have to make those assumptions. Instead, let's imagine that software exists on a continuum toward maintainability, and refactoring is the work that we do to make our code as maintainable as possible. So, what do we mean by maintainable? Well, when software is maintainable, I'm looking chiefly for 3 things specifically, and I would like you to think of these as constant works in progress on a software product. Refactoring is the thing we do to give our software more of these qualities. So firstly, we want software to be collaboration friendly. So how can other technologists maintain this code together? This is a thing we most commonly associate with refactoring, and we want to leave code clean and organized so that other developers can figure out what it does and why. So who does this well, right? Well, I have a few examples for you. So the Spring framework, as an example, makes pretty exemplary use of documentation and rigorous tests and thoughtful syntax to keep the code legible and thoroughly explained so that their distributed team, and outside contributors too, can understand and improve the way that Spring works. Let me give you another example. Apple's programming language, Swift, aims to enforce some collaborability on Swift projects. So Swift is a compiled typed language, and it leans on optionals for null checking. It includes a lot of features to ensure the safety and legibility of the code written in it. You can see that commitment to concise, legible code in the source, which is also on GitHub. Now, when code isn't collaborable, we end up with these arcane legacy systems that developers are afraid to touch for fear of breaking them. If the situation gets dire enough, the company may commission a complete rewrite rather than maintaining the existing system. We want software to be collaboration friendly so that we can avoid that. We also want software to be dialogue friendly. That is, how does a user or developer share their expectations about this program? The feedback cycle is an important part of software development. So if we want to develop maintainable software, that software has to merit maintaining by being used. And in order for software to be used, we need to make sure that it keeps up with what users and development teams expect it to do. So how do we do that? Well, when we deploy apps, we might do user testing. Or sometimes we use App Store ratings to get information about how our product is doing. Here I'll provide another example. So Google's products often provide mechanisms for users to share how their expectations differed from what they got. These particular dialogues appeared while I was looking up how to do something in Gmail. I can choose whether I found the article helpful, and if I didn't, then Google shows me a text field where I can explain what I needed. Software that fails to open this dialogue ends up getting out of touch with user needs, and it becomes shelfware. So we want to avoid that. The third aspect of maintainability is resilience. How does the code react to unexpected or unideal inputs? A resilient app anticipates things that a user could do, and it reacts gracefully even when something happens that it didn't anticipate. When software isn't resilient, we end up with failures where the software is clearly not working as intended, or where the development team didn't anticipate something that could happen, and it can end up with crashes or other really messy situations. So let me give you an example. I once worked on an app for ramp agents working on the tarmac at airports. They were scanning luggage with it, and mail, military equipment, hazardous materials into the holds of commercial airplanes. So API clients made calls to a server in real time in our first version of the app to scan each bag, and they returned updated information about the whole flight. It was all calculated on the server with each call. It was really cool. We sent it to the tarmac for user testing. The product owner came back to report that ramp agents spent 10% of their time with the app scanning bags. So what were they doing with the other 90% of their time? They were walking around on the tarmac, holding the phones up in the air. Why? Because this was the most likely way to get a network signal, and a network response blocked every single scan. The app was essentially unusable for their purposes. It wasn't going to work. So we completely refactored the app. And this time we held the question in mind, how much stuff can we do without any network connection? We couldn't coordinate scanning between scanners this way, so we assigned each scanner to a pit in the hold of the plane, and we queued up the scanning requests. Then at the end of scanning, ramp agents needed a network connection to check some security things. They could guarantee that network connection by plugging the phone into a networked holder called a cradle, and they did that just once at the very end of scanning. We took an existing app that didn't do at all what users needed and translated feedback into changes that worked. This is an extreme example that I chose for clarity, but this happens on a lot of software. The requirements just change out from under you, and you need to adapt. We write maintainable software precisely so that when the underlying requirements change, our code is ready to change too. Because writing maintainable software means assuming our assumptions will be wrong. Software has to change when it was originally written under assumptions that are not true or assumptions that are no longer true. So how do we hedge against the possibility that our assumptions are wrong? We can do that by noticing and examining our assumptions. As I was developing this talk, Kenneth Mayer asked me on Twitter, when is enough refactoring enough? And I think it will be helpful to approach this question with an example. So we have this popular concept of DRY software engineering. DRY stands for don't repeat yourself. It's an adage that developers learn to avoid duplicating stuff in code. But there's an issue with the way we interpret it. So Coraline Emke articulates that there's a misunderstanding where she explains that the point of DRY is not to repeat concepts. We don't want to repeat concepts. DRY isn't referring to individual lines of code and making sure that each individual line only appears one time. Sometimes it actually makes sense to leave similar lines of code in several places, because when you extract a variable or a class or a method for them, you are communicating the perspective that these two things are the same. And sometimes they're not. So let's look at an example. Suppose we have a class representing each view in our app. We have a list view and we have a detail view. And in each one, we need to load the view, we need to handle some button taps, and we need to load up a navigation bar on screen. Great. They both do all of these things, so it makes sense to extract a superclass. Let's call it view. Now, we're adding login to this app. So we make a login view, and we still need to load the view, handle button presses, etc. But there's no navigation bar on here, since there's nothing to navigate to until the person logs in. What do? Well, we could subclass it and no-op it to turn off that functionality. Or we could pull loading the navigation bar out of the superclass and then add it back to the subclasses that used it. That's something we could do. Maybe this is a case where creating a collaborator could be a helpful design pattern. Or creating a taller hierarchy. So a side note here is that you will see very tall hierarchies in mobile frameworks specifically because of this exact kind of thing. But if you need default functionality rather than interface adherence, and you're working with a language that prohibits multiple inheritance, that kind of pattern may not even be an option for you. So we get a new rule, the rule of 3. What is it? It's the rule that code should be duplicated in at least 3 places before factoring it out. Why? What is it about 3? 3 is not a magic number. We could factor out the navigation bar, get 8 views in, and then run into the exceptional class and have to decide between subclass and no-op, or adding the navbar method to the other 8 classes, or any of our other options. 3 is instead a rule of thumb. Because if we have to do something exactly the same way 3 times, the probability is higher that these things really are the same than if we only have the similar functionality twice. So how do we judge when to start refactoring and when to stop refactoring? In finance, when we multiply the probability of something happening and the cost if it does happen, we call that the expected cost. So we can use that in software engineering, because when I'm deciding whether or not to refactor, I want to balance the expected cost of maintenance of this code with the cost that we would be happy or at least willing to bear. This means that we need to ask some questions as we plan how to write our maintainable code. First, how likely is it that we'll have to change this? It's tough to get a definitive number here, but we can use a few cues to get an idea. So, the more examples we have in the code that support our assumptions, the more likely it is that those assumptions are still useful, and the less likely it is that we'll have to overhaul this code later. This is a generalized version of the rule of 3 that we talked about before. Also, the more customers we have using our app in the way we thought they would use it, the more likely it is that our misunderstanding of their, or rather that our understanding of their needs is accurate, and the less likely it is that we'll have to overhaul the software later. Regular feedback cycles also allow us to catch and correct differences in user expectations and software requirements early on. So it's less likely that we'll have to make sweeping changes later as we do this. By asking, how likely is it that we'll have to change this, we can estimate the probability part of our expected cost of maintenance. We still need to estimate the amount of work part. So that's our next question. How much work is this to change? Again, it's tough to get a definitive number. But again, we can take some things into account as we make a guess. So, consolidating is usually less work than separating. It's less work to consolidate our views to inherit from a common ancestor with duplicate functionality than it is to break that superclass apart again if we realize that it represents a concept that's actually too general for our use case. So for that reason, I'll tend to consolidate later and see more disparate examples of the exact same thing before I put them into one class. Also, it's usually less work to change documented patterns than undocumented patterns. This is important when deciding to go with system patterns or your own bespoke ideas for how to write software. The more commonplace the pattern you choose, the more Googleable it'll be if team members run into issues. So even if your idea is genius, if you think you'll be rolling off the project, it may make more sense for your team for you to go with a common pattern. Finally, it's usually less work to change an existing system than it is to start over. Refactoring the scanning app. For ramp agents, it was a monumental task, but it still involved less work than rewriting the app would have been. Even sweeping refactors can save the team down the line from needing to do a complete rewrite. By the same token, replacing the plumbing in a building may be an expensive and onerous task, but it still beats ripping down the whole building and starting over. That's why it's worthwhile for teams to make these sweeping refactors, and it's worthwhile for technologists to build their skills in making sweeping refactors. So we agree that being able to make sweeping refactors is important. Now we have to talk about planning and selling those refactors. In many cases, sweeping refactors require some negotiation. Stakeholders don't love to hear that we need to sink a bunch of developer time into a major change that won't result in more navigation or content features. To them, that sounds like a lot of risk for no upside. As I was developing this talk, Brent Halliburton asked me on Twitter, as a product manager, what can I do to help my engineering team be successful in appropriate refactoring over the life of the codebase? So, here's the information that a product manager can collect to make space for the development team to refactor. 1. What future developments does this change affect, and how does it affect them? People respond to the prospect of losing something. The product manager can figure out, what perceived pain or loss does this change address? Maybe refactoring an inefficient server pattern will allow your company to save $8,000 of the $10,000 it's currently spending per month on AWS costs. Maybe this refactor allows multiple engineers to more easily work in the same part of the app, so work streams don't get blocked and executives don't pay developers to sit around waiting in line to deliver code. Finding that pain or loss will help product managers make a case for a sweeping refactor being mission critical. The tech team might know something about that pain or loss, but the sales team, the product owners, and potential customers can also help uproot these worries that the changes can address. So the second thing to gather, how can we maximize value delivery over the life of making this change? Now here's what I mean. If we have to make a sweeping change, how can we incrementally perform the change to produce benefits from the very beginning so that the business doesn't have to wait on results? Suppose, for example, you have a server that clients can query for the contents of federal laws. It's a lot of text and the responses take a really long time to serialize and deliver over HTTP. But also, no human can effectively interpret that much text at once, so you don't even need it all from one call. You're working on a filtering feature, so this endpoint will now only serve the most relevant pieces of text for what the user is looking for, and you never want the call to take as long as it currently does. How do you deliver user value before the new filtering feature is done? Maybe you can set up a temporary endpoint that delivers the most read pieces of text and redirect to that while you finish the filtering. Or maybe you can pre-populate some suggested terms and make an interim version of the filter that only serves up results from those terms. It's valuable to think creatively about the question, How do I deliver the most value to the user with the smallest amount of work? The best tech teams can leverage this question to sneak through monumental undertakings, piece by piece, delivering value the whole way. Let's also talk about allies. So even with the best sales strategy, sometimes your team might need a little help to get buy-in for a sweeping refactor. Who can you turn to for help? You have a few options that are often overlooked, so I'd like to highlight them. First of all, there's the sponsor of the project. This is not necessarily the end user. If you're writing an app for a health insurance company's enrollees, the enrollees are the end user, but that's not who creates demand for the app. The demand comes from the insurance company's clients. That's usually employers who offer this insurance to their staff. If you can convince these sponsors and the people who speak for them that this refactor is important, you can open doors that otherwise might be closed. So you can also turn to the arguing stakeholders for help. It can be annoying when stakeholders have conflicting views on what you should do in the software, but conveniently, if your refactor furthers several of these stakeholders' goals, it might skyrocket to the front of the priority list by virtue of being the only thing multiple stakeholders agree on. And finally, the person who wrote the software the first way. If you're refactoring something, that means it was originally written some other way. It can be tempting to denigrate the original choices and even the people who made them, but I recommend doing the opposite. The people who wrote it the first way might have intimate knowledge of the technological or institutional limitations that forced the original design. They're also the ones with the most practical perspective from which to advise on how they would do this feature if they had it to do again. I recommend valuing this person's work and seeking their counsel. I once worked on a rewrite that would have gotten completely blocked on some idiosyncratic API details known only to the person who wrote the thing we were rewriting. Without his help, the rewrite would have failed. We ended up naming a whole menu in the rewritten application in his honor. To wrap up, we generally think of refactoring as improving the design of existing code without changing user-facing features. That's a hard line to draw, and I don't think we have to draw it. Instead, we can focus on making our code more maintainable, more collaboration-friendly, more dialogue-friendly, and more resilient. We can do that by making an effort to notice and examine our assumptions and to consider the probability that the cost of our assumptions might be wrong later on. This puts us in a good position to adapt our software to change. And change, even big change, is often more practical than rewriting software from scratch. But how do we sell the business on big changes, especially if they don't come with obvious changes to the software's functionality? We need to practice the psychology of refactoring. We can identify the pain that our refactors address and sell our ideas that way, then plan our work so that we deliver incremental value the whole way through. And when it comes to it, we can reach out for help, remembering that sometimes that help might come from some unlikely places.